Hi, I'm Vivek Vaidya, a senior principal scientist at Concerto Health AI. I work on AI models for oncology. Today I'm going to talk about an AI model to impute ECOG scores when missing in real-world patient data. This is based on a research abstract that's part of the ASCO 2020 Virtual Scientific Program. ECOG PS is a strong prognostic indicator of cancer outcomes, and scores of 0 to 1 are often required for clinical trial enrollment. Unfortunately, ECOG PS assessment is frequently unavailable in real-world settings. Since patients treated in non-trial settings therefore do not often have these scores in their structured and unstructured data, it becomes very challenging to incorporate real-world data from these patients into external control arms. To help address this, we build and analyze a machine learning model that can impute ECOG PS scores using information from different points in the patient journey. As illustrated below, we build machine learning models that impute ECOG at initial diagnosis, metastatic diagnosis, and final evaluation using a curated NSCLC cohort of 31,425 patients with at least one ECOG PS score. The XGBoost classifier was the highest performing machine learning technique. Our logistic regression baseline was 69% worse. One thing that you can see in the diagram at the bottom is that you can talk about past data and future data, and we'll sort of show the impact of how we set up this imputation problem and how it affects performance in the following slides. The data-driven approach used 22,000 features, including previous ECOG, information from the future, encounters, medications, and the latest lab value for all labs. The selected features approach was much more focused, using only past data and a restricted set of features, such as age, stage, number of comorbidities, and transformations of key labs. So here are the results for the data-driven model. One thing you can see is that AUC is pretty good. It's 0.81, and we also have a PRC average precision of 0.87 for good ECOG, and AP of 0.72 for poor ECOG. So that suggests that for the problem of deciding which patients have a good ECOG, the model really can give you has some very nice characteristics. One thing that also can be done is selecting different control points on these precision recall curve, depending on what the trade-off that you might want to make between precision and recall, depending on the problem you care about. The confusion matrix also illustrates that because of the nature of the population and the classifier, that it performs very well on pulling out good ECOG patients. And if you wanted to isolate poor ECOG patients, the performance is not quite as good. So the results for the select feature model are similar, and that's quite interesting to me. So AUC is 0.77, which is just a little bit less. AP is 0.83, and for a good ECOG, and 0.67 for poor ECOG. So just a little bit less in both. And so what this kind of tells us is that we can build this much more interpretable and focused model and get almost as high performance. Both of these, is discussed before, we're using the XGBoost classifier. So both models, machine learning models discussed in this presentation, had high rates of accuracy. Our complete abstract discusses an even wider range of different options, but we just wanted to sort of focus on a couple interesting things for this talk. One useful additional finding is the error was rarely greater than a single ECOG grade. And since ECOG PS is a subjective measure, which is not necessarily going to have, say, the same inter-observer result, this suggests to us that ML-based cohort assignment of ECOG PS scores will be of sufficient accuracy to for the applications that we thought of around clinical trial studies, inclusion, and external control arms. That said, of course, further research will be required to assess if these ML predicted cohorts have different outcomes than physician indicated cohorts. This is just the beginning of the process of understanding the ways that machine learning can be brought to bear in this space. Thank you for your time.